So we're going to expand 2x squared plus y to the fourth to the 6th power, and we're using binomial expansion here. So I'm going to have trouble writing small enough to get this across the screen, so it might kind of carry over into a second line, but we'll go with it. All right, so we'll start with our coefficients. What are the multipliers we're going to use for the 6th power? It's going to be the 7th row of Pascal's triangle. So it's going to be 1, 6, 15, 20, 15. I'm going to drop down here 6 and 1. Okay? That's the 7th row. Remember, you're always looking for, if you're raising it to the 6th power, you're always looking for the row of Pascal's triangle that's second entry is 6. That tells you what power you're raising it to. And that's one of the patterns that we noticed when we were doing our exploration on Friday. All right, so now I'm going to take this first term and the powers of 2x squared. We'll start with 2x squared raised to the 6th power. And then we'll do 2x squared raised to the 5th power. 2x squared raised to the 4th power. 2x squared raised to the 3rd power. It's almost kind of becoming rhythmic. I might break into song. 2x squared raised to the 2nd power. It's kind of like the thigh bones connected to the hip bone. Y'all know that one? Parents never taught you that one? It's private school kids. All right. Y to the 4th, we're going to go backwards. So we'll do y to the 4th raised to the 6th power. Y to the 4th raised to the 5th power. I know this is kind of crammed up, but y to the 4th raised to the 4th power. Y to the 4th raised to the 3rd. Y to the 4th raised to the 2nd. Y to the 4th raised to the 1st power. And then y to the 4th raised to 0. Now this is where you can do a quick check, right? Because we're raising something that already has an exponent, our final answers aren't going to have a degree of 6 in each term. But at this point, all of our exponents should add up to 6, right? There's a 6. 5 and 1 is 6. 4 and 2 is 6. 3 and 3 is 6. 2 and 4, 1 and 5, and then 6, right? So all of the exponents, all the powers that we've put into the problem still add up to 6, so we can check ourselves there to make sure that the pattern is set. So now it's just a matter of raising these powers, and 2x squared raised to the 6th power. 2 to the 6th is 64. 64x to the 12th. You got to remember, I noticed some of you did not do your laws of exponents correctly on this. You didn't multiply exponents there. Some of you added exponents instead of multiplying. And then 2 to the 5th is 32. 32 times 6. 30 times 6 is 180. 2 times 6 is 12. 180 and 12 is 192. X to the 10th. Y to the 4th. Plus 15 times 2 to the 4th. Right, 2 to the 4th is 16. 15 times 16 is 225 plus 15, which is 240. X to the 8th, right? 240. X to the 8th. Y to the 8th. The next term is 20 times 2 cubed. That's 20 times 8, which is 160. X squared cubed is x to the 6th. Y to the 4th cubed is y to the 12th. So that's these. Just one term, 2 terms, 3 terms, 4 terms. So now I'm on this one. 15 times 2 to the 4th is 60, right? No, 15 times 2 squared. 2 squared is 4. That's 60. X to the 4th y to the 16th. That takes care of that one. 2 to the first power is 2 times 6 is 12. X to the second power, y to the 20th power. And then the final term is going to be y to the 24th. Now, do you see any patterns here in these terms? There should still be some patterns that we can see, and if the pattern's off, then we probably did something incorrectly. What's the degree of each term? What's the degree of the first term? The degree is 12. What's the degree of the next term? 14, 16, 18, 20, 22, 24. So there's still a pattern that you can kind of see, and there usually will be with binomial expansion some type of pattern that kind of comes into play. You can't really use that pattern directly to check yourself, but you can kind of help yourself out there. Now that took us right at 5 minutes to do, but just imagine how long it would take you to multiply 2x squared plus y to the 4th to the 6th power. And that's a lot of expansion, multiplying, combining like terms, So we can jump straight through it here in 2 lines. Okay? It's actually 2 to the 6th, which would be 64 different multiplication operations that you have to perform to do that. All right, what else? I think there was some questions on the last one. What was the last problem there? Is everybody okay with this? Who asked for this one? Victoria, you good? Okay. All right. What was the last problem? Zach, what was that last one?
2m minus 1 to the 6th.
2m minus 1 to the 6th. Now, what's the tricky part of this problem? The negative 1. You've got to be careful with the negative 1. If we're not, we're going to make some errors. So we're still using the same coefficients. We're using the 7th row of Pascal's triangle, which is going to be 1, 6. I think I can maybe get this one in. 15, 20, 15, 6, and 1. Let's squeeze something in down there. Okay. Now, the 2m's are going to start in descending power, so 2m to the 6th, 2m to the 5th, 2m to the 4th, 2m to the 3rd, 2m squared, 2m to the 1st, and no 2m. But we're going to start out here with negative 1 to the 6th. This is going to have, I'm going to put them above, negative 1 to the 5th, negative 1 to the 4th, negative 1 to the 3rd, negative 1 squared, negative 1 to the 1st power, and then no negative 1. So what is that negative 1 going to do? 1 to any power is just 1, but the negative is going to make the signs change, right? So the even power terms are going to be positive. The odd power terms are going to be negative. So my odd power terms are going to take on negative value in our final answer. So this will be 2 to the 6th is 64m to the 6th. This one's going to be negative because negative 1 is being raised to the 1st power. So 6 times 2 to the 5th, that's the same as we had last time, right? 192. Was that 192? Okay, 192m to the 5th. And here negative 1 squared is positive. 15 times 16 is 240m to the 4th. The next term has negative 1 to an odd power, so it's negative. 2m cubed is 8m cubed times 20 is 160m cubed. And then the next term is positive. 15 times 4 is 60m squared. And then we're going to have a negative because negative 1 is being raised to the 5th power here. 6 times 2 is 12m. And then negative 1 to the 6th is positive 1. So that's the expansion of that polynomial. Now, that problem is a little bit more in line with the type of problem that I would ask you on a test. Okay? The other ones, it's good to kind of practice the skill, but they may be a little bit lengthy to test on. But you should be able to do this problem. It took us a little less than 3 minutes to do it together there. So you should be able to walk yourself through that problem in enough time to put it on a test. Okay? Just got to have a long blank for you. But here's what I might ask you for on the test. I might ask you, what's the fourth term of this expansion? How would you answer that question? What's the fourth term of the expansion? Negative 160 m cubed. So that may be what I ask you instead of having to write the whole thing in the blank. If you know the process, then you'll be able to get the fourth term correct. All right? So we're only doing one set of arithmetic there. Okay? What else? Any other questions from that assignment? Okay, so you better with the pattern? Is the pattern, do you have the pattern, is it yours? All right, so what I want you to do now